Okay, let's see. First of all, give me a feel for how the online lab went. Were you able to get in and do everything from home? Okay. Yeah. Anybody not able to get in that tried? How many of you have tried it so far? Okay. Okay. Obviously, we're doing this for the first time out with live equipment in the line, so I'm particularly interested in how this works. We've done online labs, but they've all been virtual machine based. So once you're in there, that's pretty much it. Yeah. And this is kind of an order of magnitude past that. So, okay. Let's see. Let's go ahead. I didn't come back to this on Friday because I wanted to go ahead and get in the lab. I wasn't sure what to expect. So let's go ahead and finish this up. As I recall, we had discussed our way through Site 1 completely and still needed to do Site 2. Is that accurate? Is that where we were, or did we finish? I've taught this a lot of years. This problem has been here a while. So we haven't done any of the rejects. Okay. Okay. So basically what we've done is gone through and identified number complete templates. And the way I got you to think about this, types of calls. If I'm sitting at one of these switches, remember that what the switchboard process, the routing process, if you will, does in each one of these switches is decide which interface matches the pattern on this call. Okay? To make our life easier, if we can group our calls and do those number complete templates a little more generally, makes our life easier. Are there times when you need to put a less general one in? Sure, we're going to have one in. Guess what? Another problem today. But the point is, you don't make those any more specific than you need to accomplish the task. Okay. Now, accept rules on interfaces need to be very specific. That's where I was saying you want to make sure that the accept rule on the interface only defines exactly the range that should go through that port. No more, no less. Okay. So we've got two different things going on there. We got through that part in Site A. Are there any questions on Site B or Site C? Anything other than the rejects about how you'd handle that? Pretty much the same thing. We'd look at, if I'm at Site B, well, I'm going to have calls within this site. I have calls to Site C. I'm going to have calls to Site A. I'm going to have calls to the LEC. I'm going to have calls to long distance. I'm going to have calls to 911. Since we're requiring 9 as a steering digit or an escape digit, you'll hear the term, I'm also going to define 9911, just so that both of those work immediately. One note to kind of keep in mind, this number complete template list, as the switch receives digits, as you dial, the switch is accumulating those digits. And remember I said as soon as it makes a match, it will make a routing decision. So you want to put the rules at the top that are most likely to be matched, because every time you enter a digit, it goes through that whole list, top to bottom. Okay. What I usually see, what I do when I did, I guess is probably a better word. Good practice is to put 911, 9911 at the very top. You want those to match right away, no exception. Below that, think about which calls are most likely to be made. Absent any other evidence, the geographic rule works best. You're more likely to call people physically closer to you than further away. So if I'm at Site B, unless you have evidence to the contrary, your best assumption is that people there are most likely to call other people at Site B. Then Sites C and A, geographically from the point of view of our dial plan, and then the rest of the world. So that's the way you'd stack your orders. It used to be that this was a processor saving technique. Now it's just making your calls go through quicker, so you can check things easier. So we're not going to pay a whole lot of attention to that, but it's just kind of a rule, best practice kind of thing. Okay. Now, do we need any reject rules in this?
Is site A the top phone can't make long distance?
So how do we do that? Let me ask the question this way. At site A, is the general rule to allow long distance? How have we defined long distance at site A? What's our number complete template? Yeah. And we could do it 1 NXX, NXX, XXXX. You could do $1 sign. We're going to talk about some options like that and the problem we're going through today. Which one's right? Depends on where you're standing. If you have a relatively simple dial plan, or you know long distance is always going to steer one way, then use $1 sign. If you need to specify an exact number of digits, then use 1 NXX, NXX, XXXX. Okay. In this case, what we've said is the phone attached to interface B is not allowed to dial long distance. So let's say that phone picks up, we don't have a reject rule in place yet, that phone picks up, dials 1 area code, exchange 4 digits. What does the switch do? What's the switch's thinking process? Remember, we went through that whole thing. Okay. As you dial, what's the switch doing while you're dialing? It's watching the templates, and it's gathering numbers from you until it matches one of those templates. Since the dial templates we put in place the last time we talked specify an exact number of digits, oh, there it is. We have specified that long distance is 1 NXX in XX, XXXX. So, as soon as the switch sees a leading 1 followed by 10 digits in this pattern, 2 through 8, 10, 2 through 9, 0 through 9, 0 through 9, so on and so forth down the line, then it will make a routing decision. What would it do if I put that up? And actually, I just asked you a question that's not fair. This actually can't be used as a template. I got ahead of myself. This can be used as an accept rule, but you can't use it as a template because templates must specify a number of digits. I'm sorry, I didn't mean to confuse you on that. Okay, so as excuse me, as I'm dialing, the switch is collecting digits and matching those templates. Assuming the only thing I have in there that's going to match long distance is this one, I'm going to have to give it a total of 11 digits, leading 1, followed by the area code exchange, and 4 digits. Once that matches, then what does the switch do? Absent a reject pattern. Finds all of the matching interfaces, right? So what have we put in here? Looks like on our notes the only thing we put in was on interface A, this as an accept rule. Okay, well, we have one match. I'm going to take the best match out of a list of one match. It's pretty easy to pick the best match. So I'm going to route it to the interface associated with this, which in that case is interface A. If I want to keep that phone from dialing long distance, I need to interrupt that process. And remember that what the switch actually does is the very first thing is it checks rejects. That was on that same slide, although I didn't make a big deal of it. it actually goes in and checks rejects before it checks accept patterns. If there is a reject, it'll see if it applies to the pattern that you've done. Okay. So, if I want to keep this from going through that port, interface B, I'm going to say reject, and different switch manufacturers, you'll see different words. Reject is one. Block is one you'll see. It's pretty clear what they mean, but the idea is I specify a pattern that is not allowed through that port. So 1, NXX, NXX, XXXX. If I want to block all long, what is this block specifically? Long distance in North America. Okay. So now, if we put this reject on interface A, what's going to happen? Let's go back through our scenario. User picks up the phone, starts dialing digits. We're matching number complete templates. As soon as we match the number complete template, it's going to check the reject list. Well, now we have a reject that matches that number, and it is associated with whatever interface it is, interface A. So the answer is going to be, I'm not going to let that call go through. Different equipment will do different things. The simplest thing you hear usually is a fast busy. You know, sometimes you'll get a recording. This extension is not allowed to make long distance calls. Depends on how nice the person programming the switch wanted to be, basically, how polite. So the thing to remember is that basic structure we did. Actually, let me go back to that switch. When we were looking at this, just remember the process going through here. You know, we dial a number. There's our number complete template. It matches. Then we check and see if there are any reject templates. It does match, so this call will be stopped. You know, we just block it. If, on the other hand, I dial from another phone attached to a different interface, number complete matches, there's no reject, that matches, then I can go ahead and pick the best match out of all the remaining matches and route the call out that port. So the key is, where do we put that reject rule? And it sounds simple. Well, I've given you a simple example. We don't want the phone on interface B. Where would we put, to be able to dial long distance, where would we put the reject rule? And there's a reason I'm asking it this way. I'm sorry?
Interface B.
Right. I'm going to put it on interface B because I only want it to apply there. Excuse me, I'm about to talk myself out of a voice for some reason. You use rejects to stop a call that would otherwise be allowed through a port. You don't use a reject usually to stop all calls of a particular type. You can. It gets confusing if you get 3 or 4 of those rules in and then you get a couple of changes of personnel. Then it starts getting weird when numbers don't work. So it's better to do this kind of very selectively. What happens if I put that reject rule on interface A? That exact same reject rule. Nobody can dial long distance. Exactly right. What if I want to stop everybody at this site from making 900 number calls?
Would you put 1 900 NXX, XXXX?
Okay.
Interface A for reject?
Yes. Thought process. Here's the number being dialed, 1 900 whatever whatever. I'm going to match my number complete template. I'm going to see a match for 1 900, a reject match for 1 900.
So when you put in the reject rule, you put the 1 NXX, NXX,
I'm not sure what you're asking me. You write a pattern that matches exactly what you want to reject, and then you apply that to the interface where you at which you want to block those calls.
Reject rule on interface B, we just put the long distance.
Yes. What if I said, oh, well, there's 900, there's 977, there are 2 or 3 of these. I'll just cover it all with that. What have I done? What if you want to call, what's the area code in Dyer? Okay. What if I want to call Memphis? 901 area code. I can't call Memphis because I've stopped it. Okay. So you have to think through this like a machine, a computer. Computers aren't smart. They just do what you told them really fast. In this case, I'm telling them to block anything that begins with 19 followed by 9 digits. Okay. So you have to be very careful with that. Things that I see done wrong out in the world. Unnecessary rejects. So, for example, if I usually put in the requirement just to kind of get you to think about 911. The 911 has to route to the local leg. You'll see people think, oh, I want to be really sure that happens. So they're going to put a reject 911 on every interface. I mean, I've watched people spend hours doing this. It's like, really? How does the switch work? We match incoming patterns. We look at the rejects. We look where the matches are, and we're going to send it to the best match. Not much is going to match 911. That's kind of why they chose it. Other countries use 999, I think. But same idea. Don't put in rejects just because, oh, I don't want something to go here. Rejects are for blocking calls that would otherwise go through a port. If I don't have an accept on a port, 911 is not just going to magically jump over there and go through, so I don't need to put the rejects there. Okay. Looking at site A again, let me make one other point. We have defined a situation where we have long distance going out interface A, where we have local calls, as in LEC calls, going out interface A. We have calls to site B and C defined on interface D, and we have individual extensions defined on interfaces B and C. Could I do interface A some way other than specifically saying, NX9, NXX, XXXX, and 1, NXX, NXX, XXXX? What I'm asking you is to think about the types of calls you've got. Look at the number complete templates we have. Yes, sir? Mm-hmm.
You were not on the accept rules. You were not put the long distance accept rule on there. What happened?
Okay, the question is if on interface A we did not put the accept rule for long distance 1, NXX, MXX, XXXX, which is what we've defined. The way we've built this dial plan, absent that, let's think through it. I'm sitting at interface C, okay, since we put a reject on B. I'm sitting in interface C. I dial 1 area code, exchange, and 4 digits. We have a number complete template for long distance, right? So once I put 1 area code, exchange, and 4 digits, what's the switch going to do? Right. Where are the matches? And what's going to happen? Right. No match means nowhere to send this. So it won't route.
I guess it works the same in this situation, but in those situations that wouldn't work out. But I don't think it's for side A, we wouldn't want long distance. I'm just saying for this instance, I guess it still kind of works. They still wouldn't be able to make long distance out of side A.
Right. They would not be able to make long distance at all because you hadn't pointed long distance anywhere. and no match is no match. That actually relates to the question I was asking. Is there an easy way, if I had all my on-net calls defined, and this is all I had for a network, which is not a very big network, is there an easier way to deal with what I want to send out interface A? Sorry? Yeah. What does $ match? Specifically. Tell me what dollar, we said X is any single digit 0 through 9. What is $? Any number of any digits. So it'll match 9. It'll match 9999999, on out. It'll match anything I put in there. But it is a match. Okay? A very general match is still a match. No match is no match. So the other way to handle that, is to put a $ on interface A. If it is not my local site call, which I already have a specific pattern for, and it is not, excuse me, a call to site B or site C, which I already have a specific pattern for, then send it out interface A. We've created a default gateway in essence. It's not what they call it in the PSTN world, but that's what we've done. Here's where you send calls you don't know what else to do with. Now, the PSTN may not be able to match them either, but that's where you've sent it. Okay? It's actually pretty common. You need to be a little careful with it. For one thing, you can't have $ on more than one interface. You can, but it's going to be, you can do it. It'll let you do it, but it's going to be real unpredictable as to what happens. Because now I've got two very general matches tied with two interfaces. Some switches won't let you do it. Ours actually will. Just kind of think through that sort of thing. You don't have to build, you don't have to specifically list every number you dial. Sometimes it makes sense to break them out. Sometimes it makes sense to combine them. I'm going to give you some more problems so that we can kind of work through that. We're going to do a lot of this during this semester. Okay? Let me ask something. Actually, I'm going to hold on to that thought. Let's go to the next problem here. It'll make more sense after this one, I think. Same idea, just a different looking network. I've got 3 sites: San Francisco, Nashville, and Atlanta. I have, in this case, assigned DID numbers, which is direct inward dialing. In other words, these are public numbers, routable on the public switch telephone network, to each of those sites. San Francisco has area code 718-265-1100 through 1249. Atlanta 404-472-8290 through 8359. Nashville, you can see that one. Okay, here are my requirements. There's our 911 and 9911. 4-digit dialing within a site. So I'm going to dial 4 digits to get to another extension. 5-digit dialing between sites. Okay. 9 plus 7 digits to get to the LEC. 1, 9, and 10 digits to get to the IXC. Okay. And the IXC connection, which is in Nashville, is used by all of the sites for long distance. So if you're making a local call out of Atlanta, it goes out to your LEC. If you're making a long distance call, it's going to route across your private network to Nashville and then out your IXC connection. You still see this somewhat. Voice over IP has, as enterprises switch to voice over IP, you see this kind of thing disappear. In networks that haven't switched, you still see it because I can go to a long distance carrier and say, look, I'll give you all of my long distance, but you have to give me a better rate. Okay, so you still see this sort of thing. Everybody's long distance routing. Usually you have it so it'll fail over to the LEC. Pair off, no more than 3 together. And let's see what our time looks like here. Let's take a little bit of time and come up with number complete templates for each site. what kinds of calls are you going to have for each site, and how are you going to define them? These are not routing rules. These are number complete templates. Okay? So let's take, let's take about 5 minutes. It's 12:59 now. I'll check back with you at 1:05. In the online classes, you're watching the recording for this. Go ahead and just work along. I'm going to leave the recording running so you can hear questions as they're asked. And probably hear me drinking my Coke. Actually, I had this all written out and prepared to give to you, and I didn't give it to you. Mm-hmm. Oh, I already gave. Did I give you one? Okay. Yeah. Put yourself inside the switch at San Francisco and identify number complete templates, which means I want you to identify what different types of calls within this site, calls from San Francisco to yada, yada, yada. beg your pardon?
That's the convention.
You see where I'm going with it? What happens when you throw in an interface that moves? Okay, let's go ahead and look what, if I'm sitting at San Francisco, what kinds of calls have I defined that we're going to make? 911, so we're going to match that with, cleverly enough, 911 and 9911 because we're requiring a 9-digit escape digit, and if the big 7.5-foot tall guy with a knife is coming after me, I might hit 9. Yeah. It's not going to be my clearest thinking moment, certainly. Okay, what else? What else can San Francisco do?
Within sight.
Okay, yeah, we can call other sites at San Francisco, and specifically we're doing 4 digits. So, what's my number complete template? I'm sorry? Yeah, just 4 digits within a site. Could I do that? You knew I was going to pop that back up after. What happens when I mean, this is probably the most common early on mistake. What does this match 4 digits at a site? Absolutely, matches it well. What does it also match? Any other 4 digits you're going to dial. So I've got to take my 4 digits at my site and match them. Now, if you have a highly complex network, think dozens or hundreds of sites, you're going to want to make this exactly the same as your dial pattern for the sites. In a simpler network like this, we don't have to be that specific. So what can we do for a pattern? Whoops. Too many digits.
Okay. I did that at first, but it doesn't work out because with the long distance calling, you do 1 in XX and the N is 2 through 9. So if somebody dials 1, 2.
Hold that thought. Excellent question about 2 patterns back from where I want to deal with it. Give me just a moment, okay? That was one I was hoping somebody would catch. Okay. Everybody okay with this one? Anybody have anything else?
Well, the last digit can be an S, but you can't, if you stop at 4, you don't want an S there.
Remember, this is a number complete. Good point for a match. That's not what this is. This is a number complete template. What's the purpose of a number complete template?
Tells you what numbers will complete.
What does it tell? What's its in the switching in the telephone switching process? What does this inform that it is a complete number?
It informs that after 4 digits it's complete.
Yeah, I mean, I'm trying to get you to think more specifically. This is used to tell the switchboard process, the actual routing process, that it has enough information to route a call. So I don't have to specifically match.
You just have to know that it has enough information.
Right. This has to uniquely break out a type of call. That's as accurate as it has to be.
So as long as it's more than just 2 numbers, you can put an X or
Be careful with generalization, yeah.
Well,
Yeah,
no,
you can.
I'm
In other words,
I'm not, it's an X or an N or whatever is required.
and that's what we're going to come back to on this long distance question. You know, here I have a pattern that starts with 1. What do I do with that? And we're going to come back to that because you guys are used to thinking IP. Okay. What else can we do?
So get on the private network at the 5th
Okay.
digit number.
Private network. We have 2 other sites on the private network. So what do I need to put at San Francisco for private network calls?
Well, if it's a 5th, you need to use common nomenclature, right? So you need to put, since you're already using 9 to get out
Okay. So 8.
And then the four-digit template for another.
Okay, let's do Nashville first. So 8. What would my 4 digits be? Oh, okay, yeah, 8, right. And then bracket 6, 7. Then what? XX. Okay. What about Atlanta under this scheme? 2. Oh, okay. I'm sorry. 8-8 2 3 XX. Does this work? Yeah, works just fine. Is there another approach that somebody came up with? Understand that at this point, you're not trying to find the right way. You're trying to find a consistent solution. There are a lot of ways to do this. I will, at the end of maybe the end of today, certainly at the end of Wednesday, give you my solution to it, but it's not the only possible solution. Okay. Is there another way that we could approach this? In other words, in this case, what we've done is just kind of follow the idea that we're using 9 to get to a local call, 1 to get to long distance. We'll use 8 to get to an on-net call, followed by the patterns for the different sites. Could I simplify this? Let me put it that way.
Yes.
How?
Just do 8-8 bracket 2, 3, 6, 7 bracket XX.
Okay, so 8, 2, 3, 6, 7, XX. That'll work. Those two are equivalent. I'm sorry, 8, that is. By the way, dial plans ignore punctuation, so except for specific ones we'll talk about. The other way to approach it, and I'll put this out. What did I call these leading digits? Okay. Now, let me get you to think with me for a second. Every one of these sites is doing this internally, correct? 4-digit dialing. Okay. Which means, what am I going to put on each of those individual phones? On the port leading to those phones? I'm going to put a 4-digit extension. Okay. So, let's say I'm sitting in San Francisco with this, and I'm going to dial Nashville. So I'll dial 88615. Okay. We'll assume we have the routing correct. We send it across this interface. What arrives at the switchboard here? 88615. 5 digits. How many digits did I put on that interface? Oh. We've got a problem. Got more digits than I know what to do with. The other piece of this puzzle is you have to control digits. Steering digits are meant to be used inside a site, and they are stripped off before you send them out. Deep breath, because there's a whole range of ways to do that, but it is necessary. So in addition to this, and I just bring it up to make sure you understand, we'll deal with the practical part of that. But realize I'm sending 5 digits to a place that wants 4 digits. The hard way to do it is to go back in here and duplicate every entry on the phone port. I don't want to do that. You know, I put 8615, I think is what I said, and I could put 88615. So that'll work, but that's a lot of work. What I'm really going to do is use 8 here to get it to this interface. I'm going to then tell that interface, strip off the first 8. I'm going to strip the most significant digit, the first one I send the switch. If I strip the first 8, what do I send to the other side? 8615, which is a 4-digit code, and this switch knows what to do with that. Okay. we'll deal with that a little more when we jump in the lab. I just wanted to kind of raise the pointer there. Okay.
So is that something you have to put in this rule, take off this before you send it out?
You do it on a per interface basis, yeah. We'll talk about it more when we look at trunks. It's called stripping digits. Okay. The other way you could approach this is to say, I'm going to assign a steering digit for each of my sites. Okay? So I'm going to say all calls to Atlanta are, let me put a big or on this, or all calls to Atlanta begin with 8, followed by XXXX. Oh, 4 X's. You got to be consistent across all your sites. But if I'm saying 8 followed by 4 digits, I'm okay. As long as my extensions don't begin with 8. In this case, have I got a problem? Yeah, I've got extensions that begin with 8. So I'm going to change this to something else. I could use 5, for example. Okay, and I could use, let me look at my list of extensions over there. I could use 6 for Nashville. Okay. Not a better way, just a different way. Okay. The nice thing about this one is it's easy. This is internal. I use 5 to get to the interface. I can't remember which way I said this was going. 5 to get to the interface going to Atlanta. So the C interface up here, I strip it off, and I send the 4 digits following it. Okay? So I don't have to worry about the specifics of it. 6, same thing. I send it to the D interface, strip the 6, I send 4 digits across. Just another way of handling it. Okay?
I guess the 8 is better if you want a centralized plan for all sites.
Yeah, it can be. The point I'm trying to make is I can't teach you one way to do this. You have to know what these rules are. The rules are pretty simple, but you combine a lot of rules to make a fairly complex system.
And I guess if you're making a steering digit, it can't be the most significant digit of the 4 numbers.
No. Well, you've made your life, yes, it actually can, but you've made your life real hard. And that's as far as I want to go. We'll actually look at, I've got a situation in mind for one of your labs that will do exactly that. Now, let me go back to this for a second. Question was brought up, if we define our local calls, our inside one site calls, as leading 1, possibility of 1 or 2, in the second digit place, followed by any 2 digits, will that conflict with long distance? What's the purpose of a number complete template? Tell the switchboard when you've gotten a complete number, which is why you cannot use $ in a number complete. You have to specify the number of digits. What's the difference in this and a long distance call? Okay.
This call not only has the exchange in front of those 4 digits.
The question is, not if you say 1 plus 9 plus 10, so you dial 1, 9,
yeah. For long distance, I dial 19, area code exchange. Okay.
Before the way we were doing it, we were doing 1-n, XX, represents 2 through 9.
So I've got a problem with half of my digits. Yeah.
But the 1-9 of this also.
Yeah. Okay. The other thing, so we ended up with one time where you could accidentally, they use 9 as a steering digit, which is real common. People are used to it. And in their dial plan, they ended up accidentally dialing 911 with one of their internal matches because they used 9 as a steering digit to get off this site. And one of their sites, all the calls began with 11. Okay. 9, I want to go to Hazel, and I want to talk to, Mike at extension 1102. So 911 route. Okay. That's why you spend some time looking through on this. I keep coming back to it, but be sure you know this process. This is how you think through all these issues. What happens in what order with which pieces of information. Okay. Now, I know we're right on top of it, I think. Give me 30 seconds. I am showing you the PSTN way of doing this because it is simpler while you're learning this idea of matching patterns to interfaces. Let me leave you with this thought, and I'll say, work on this assignment, bring it back Wednesday, and we'll walk through the rest of it. But let me leave you with this thought. What if one of these ports could move physically, but I want to keep the same number on it? What's going to be necessary to make a dial plan work if this port is working? Okay, you say assign it to an IP address. Okay, I want you to think through that. An Ethernet address, right? Okay, so think through that and an IP address, and let's be prepared to talk about it at the end of class on Wednesday. Okay, see you guys. If you're in the online class, I would like you to work through this the same way. Go ahead and look through the rest of the sites, come up with a number, go ahead and complete a dial plan. We're going to discuss this whole solution Wednesday, and then I will hand out a solution to it, but I want you to work through it and then compare your work to mine. The key piece I want you to understand is, A, you're not trying to get inside my head. You're not trying to guess what I would do. You're trying to solve the problem in front of you. 2, we're past the point where there is one solution to any of these problems. There are multiple ways to achieve this. So what I need you to do is to think through the process, think through your solution, and then compare it to the discussion on Wednesday.